lateral movement is really the practice of attackers moving from resource to resource in search of their goal or the highest value data on a system. And they look for network and information and credentials in a number of ways to help facilitate this movement. We'll talk about many of those methods over the next 10 minutes. Lateral movement is a key step in the Cyberkill chain, and the Cyberkill chain is a threat model or a framework built by Lockheed Martin in 2011 to give some structure to the phases a bad actor will go through to perform a hack or a compromise. And we'll use it to frame our conversation and provide a reference point this morning, if you will. And so the Cyberkill chain it's far from perfect and has been criticized for being too sort of malware centric, among other things. Detecting malware is still absolutely critical, but attacks can't all be put into that same bucket. And so the kill chain model has been generalized a bit down from sort of 8 more specific phases into the model you see here. In fact, a good example of a potential compromise as recent as this week is this Amazon Web Services S3 bucket compromise, where thankfully this was found by security researchers who informed the vendor that, and this has since been secured, but this is a compromise that would have involved no malware and in fact actually no network at all. So we're going to be focusing in on stage 4, lateral movement. I do have some supplementary information at the back of this deck on other phases, if that's of interest to anyone at all. So I'll post these slides in the Slack channel once we're done. I know there'll be video recordings available at the end as well. So lateral movement, it's a key step in this model since most often it's necessary, right? Attackers look for a way into your network any way in, even if that path is a system with no data or no potential to control whatever is desired. On the inside of a perimeter secured network, things look very different from a security perspective. And if an attacker can collect information about their surroundings, there's a good chance they can and will move on to systems closer to their goal, whatever that may be. With the public cloud, however, our networks look different, right? Perimeter defenses have given way to microsegmentation, where network firewalls surround really every workload and function. A bigger change even than that, however, though, is that bad actors now have the very same network access to the control plane of the cloud that we do, namely always on, ubiquitous access from anywhere in the world. This would be analogous to publishing the remote administration interface of your data center networking core, your storage appliances or filers, and your hypervisor on the internet, guarded only by a simple set of credentials, right? Nobody did this for good reason, but with the public cloud, this is the reality. So although lateral movement has always referred to the network, in the public cloud, it's necessary to think a little bit bigger. And look, don't take my word for it. A quick Google search for a cloud, or in this case, AWS hacking tools, will reveal a number of tools that really have nothing to do with the network, right? What you see on the screen are tools that will either query the AWS API or will search through very public code repositories, for example, for embedded credentials that, if out in the wild, could be super disastrous to your efforts on the public cloud. So we have a lot more to think about. Yes, the network plane is still very important and should be at the center of our efforts, but understanding that we have 2 other new vectors, so to speak, to watch is really, really key. Within the network plane, we have new conventions and capabilities that will challenge administrators that are new to the public cloud, such as firewall filter logs as a service, and we talked already about microsegmentation and the associated sort of proliferation of firewalls. As important as that, though, is recognizing that we must understand and monitor to these 2 other sort of vectors, right? Namely the cloud and the user planes. So the network plane, again, it's what we're most familiar with, although there are some new sort of conventions in a public cloud network. We're still looking for those things we looked at the data center, right? Weak passwords, passwords that are saved on systems in clear text. Linux shell history is a real big culprit for this one. Aging and unpatched operating system and applications, right? Attackers know that the lowest common denominator is an old system that not only isn't patched, cannot be patched, right? Because it's fallen out of support from the vendors. So those are really, really critical, as they always have been, as is malware, as are SSH keys that allow attackers to compromise further systems within your environment. It's not all bad. Some of those new conventions in the public cloud network are helpful from a security perspective, namely Microsegmentation, meaning that now we have far more firewalls around kind of, if not each workload, each function. I mean, it's great from a security perspective. It might be a bit of a burden from an administration perspective, but it does give us a lot more opportunities for security controls. And then secondly, sort of ephemeral nature of resources, right? It's becoming quite common, probably initially from a cost perspective, to really only spin up resources when you need them, perform their function, and then spin them down. Imagine a bad actor kind of lands on one of those resources with the intent of sort of camping out and discovering much more about your network, and then very shortly after that resource is sort of deprovisioned, right? That's helpful from a security perspective and an attacker wanting to create a foothold in your environment. However, the cloud plane is quite new, right? Every API call made to your cloud provider is authenticated with an access key and a secret key. We're speaking about AWS in this context, and then authorized via the corresponding permissions behind that key, right, that were assigned in AWS Identity and Access Management. So when we think about the risks on the cloud plane, they're numerous, right? The first is sort of a drop dead easy one, and that's recon for the network plane, right? I used to, as an attacker, I used to have to get into your network, look around, understand what that network topology is. But imagine as an attacker, if there was a way for me to tap into something that provided full visibility around every aspect of your network configuration. That's effectively what the cloud control plane is, right? If I can access that AWS or that Azure or that Google console with enough privilege, why would I even explore the network if I had a map to the whole thing? Second, we have this concept of AWS organizations. And if you use these, an attacker with read permissions, only read permissions, can tell if that account is a child account. And they can also tell what the account ID and the root email address of the parent account is, right? Might not seem like enough, but that's enough to begin thinking about, how you harvest credentials, maybe a little bit of a social engineering campaign. It's more information than you want, a bad actor to have, that's for sure. DNS as a service manipulation, certainly, domain name resolution redirects from something legitimate to something that isn't, and performing, malicious password harvesting, for example, has been a strategy for some time, but used to involve searching for and compromising several key infrastructure pieces, DNS, DHCP, for example. And if you're a DNS as a service user on AWS, it takes privilege but very little knowledge to make malicious changes to DNS, right? It's a click, it's a change of an entry, and away you go. So it's way easier really than ever. And then IAM permission elevation. There are several ways bad actors can elevate their permission once you're authenticated in via the cloud control plane, maybe with sort of everyday credentials. On AWS, for example, you can find a policy that's got, policies have versions in AWS, and you can find a version that grants more access than what's currently in play and set that to the default. And that requires less permission than you'd expect. You can create an EC2 instance, a virtual machine, with an existing instance profile that's associated with a service role that's got permission behind it. Once that machine is provisioned and the AWS keys are temporarily available, they'll provide access to other AWS services that the attached role has. So there are some ways to break out of the specific permission that you have as an end user that's authenticated into the cloud console. And then federated identity sort of last on this list. It's not necessarily an attack vector, but it's a configuration that puts the onus on you to ensure that you're following, account credential logon session best practices. Things like, do you have a comprehensive enough of a password policy or using multi-factor authentication? When you sort of use that federated identity single sign-on strategy, the onus for that becomes, outside of the cloud into your identity store, and that's something to be very, very aware of. And then lastly, the user plane. This is related to the cloud plane. I think that the same kind of malicious potential is there, but now we're not looking within the network for these secrets. We're looking where else users would store them, right? If I'm an administrator with access to several systems, I'm going to have a stable of SSH keys. I probably also have one or two keys to actual cloud accounts, with certain permission attached to them. Those must be guarded. They definitely not stored on any sort of convenience file sharing kind of service. but especially not embedded in code repositories, right? GitHub or Bitbucket, things, legitimate services where cloud credentials find their way into scripts for ease of use, for example. Really, really important to find those. Obviously, to have a policy not to do that, but then to find them once they do escape. And if we're following the principle of least privilege, that is, only those user accounts that need the privilege have it. We're not doing anything out of convenience, like opening up, more rights that are necessary for a particular job function. Then we'll only have a handful of accounts that really represent this much compromise potential, the damage that could be done. If we have many accounts like this, it's time to think about that principle of least privilege and why that is. So we've talked a lot about risk. Let's talk about how we mitigate that. First is, and I use the word continuously in this first point, you can apply that really to all of these. The public cloud is this ever-changing sort of map of infrastructure where, in advanced use cases, applications are actually deciding their scale, right? So your network can change very much from hour to hour, from day to day. So continuous is sort of assumed in all of these, but continuously assess your cloud identity and access management policies, your password policies, monitor multi-factor authentication use. Again, if you're a single sign-on customer, you will set some of these policies back at your identity store. If you're using native accounts within your cloud provider, these controls will be available there. So use them for sure. And then automate that search for keys. We talked about SSH keys that provide access to hosts, cloud keys that provide access to cloud plane accounts. Automate the search for those. Have something that looks and catches those before the bad guys do, for sure. Because as I showed you earlier, they do have a set of very, very comprehensive tools that are always looking for slip-ups. Ensure that all operating systems, applications, and shared libraries are patched to current, and known vulnerabilities are understood, right? The traditional vulnerability management is still super important. And as I kind of called out specifically, make sure that we're not running end-of-life operating systems that can't be patched, or end-of-life applications that no longer receive security updates from vendors. There are times when we have to do this. We know we don't like to do it, but we accept that risk. If you do, make sure those systems are especially hardened, right? And always look for ways where you can sort of break out of that paradigm, because certainly bad actors are looking for those scenarios and situations as well. I think find old outdated software that no longer receives security updates. We covered that. And then also make sure that where we're logging, that we're logging comprehensively enough. We want to make sure we do capture sort of evidence if we are compromised, and encrypted, right? We want to make sure a common tactic of an attacker is to sort of cover their trail so they can maintain persistence in your network while they sort of figure out where the high value is. Make sure they can't do that. Make sure that the logs coming out of both your I say public cloud logs, but even at the host level, right? Make sure they are secured as much as possible so that the threat of kind of removing a trail is minimized. And then lastly, with the proliferation of those firewalls, make sure that security groups don't permit traffic from the whole internet, right, or a super large scope. You will get requests for exactly that. So have a plan for exception handling, right? How do we open up a particular resource for a contractor or a vendor? The easy way to do that is to open it up to the world, but of course, that's a very sort of daunting thing. And that's it. I think hopefully I didn't run over my 10 minutes here, but Orca security is really all about everything we talked about today in terms of sort of deep discovery of those things, not only that support lateral movement, but that are a concern from a security perspective, deep within your workloads and across the cloud control plane. So yeah, that's really it.